welcome you all wholeheartedly for this day 4. Our first session will be on data connection in Tableau. I feel so glad in introducing our resource person, Mr. Sudharsan Manadan, to the gathering. Mr. Sudharsan is a senior engineer in Oracle Fusion Middleware at L&T Infotech. He's a techie with proficiency in resource, finance, project analysis, and planning departments. He's also collaborated with clients such as Terex and Marsh McLennan Groups in account payables, automation, insurance, and manufacturing. His areas of expertise include Tableau, Oracle, JDeveloper, WebLogic Server, MongoDB, NoSQL, Apache POI. He's a certified analyst in business management and also process management. He's also a certified corporate communication professional. It's really an honor to have you with us today, sir. Thank you so much for taking your time in joining us today. I now request you to take on the session, sir.
Hi everyone, I'm Sudharsan. I'm working at L&T Infotech, Chennai. Let me share my screen from. So before going inside the topic technically, let me get some idea about what extent you people are familiar with Tableau. Whether it is a theoretical, whether you all have theoretical knowledge alone or you all have practical knowledge as well. Yes, you can mention in chat. Okay, a bit of practical knowledge. We are exposed to practical aspects to not much hands-on. Fine. Before, let me tell you how I am. What is the knowledge which I have in Tableau? Actually, I'm not totally into Tableau. Into Oracle chatbot. Oracle technologies. I'm totally into Fusion Middleware. Fusion Middleware is getting data from many different sources and collaborating together and processing it in a customer requirement way. We'll be getting all the data from each and every customer. Say for example, I'm working in insurance domain right now. In insurance domain, particular insurance company will be having n number of clients. We'll be getting data from each and every client and we'll be processing and we'll be putting this data in the client readable way. Whatever the data which the client wants to get or understand, they can get that information from us. For this, we'll be using Tableau because Tableau is one of the best way. One of the best software to depict the data in a better graphical and chart way. You can easily visualize the data which they need to see. Okay, just like this is Oracle Tableau. No, this is not Oracle Tableau. Tableau is different and Oracle is different. Oracle is a separate product which can be integrated with Tableau through a driver. Driver is a middleware, it is an integration software. Say for example, if you want to integrate the data from Oracle DB to Java, then we'll be using JDBC driver. Similarly, if you want to get the data from Oracle database to Tableau, if you want to visualize the Oracle database in Tableau, then you need to have this Oracle Tableau driver. I'll tell you in a later way, one after the other. So these are the things which we are going to cover today. First two topics are how to handle data. All these you people will be familiar with. Let me tell you what is data. You all know data is going to rule the next generation from next generation onwards, because from our generation, not from earlier generation, from our generation, maybe from the beginning of 1980s, 1990s, the world started crumbling with data. Enormous data are there. Like earlier, we used to store minimal level of data in our storage and those things and all. But now the data storage has revolutionized the world. We can able to store the data of galaxies. We can able to store the data of medical information. We can able to store the data of chemical reactions, whatever it may. Each and every area, each and every domain has come up with the data. So in order to save all this data and process all this data, we need few people called as data scientists or data analysts. After getting a proper output from these data analysts and data scientists, we'll be visualizing them for common people. Okay, sure. Oh. Okay.
It's not. So you there?
Yes, I'm here.
Okay, sir.
I just made it a full screen sharing.
Yeah. Okay, sir. Okay, sir. Go
Okay.
ahead, sir.
Like so you all have got to, I mean, you all have got some information about this artificial intelligence, deep learning, machine learning, human computer interaction, robotics, and everything. Now the data has come into plunge. Say like just for making a robot to do some specific task, we'll be writing enormous amount of codes and those things and all. It needs a lot of data to understand what is happening around him. I mean, around him or her, whoever it may be. Maybe it may be a machine or it may be a human. They need to grasp the data, they need to understand it, they need to analyze it, and then they can visualize. Simple, like a kid visualizes the data through its mind. Say, for example, let's take a Lament example. 1 plus 1 is equal to 2. First, the kid visualizes what is 1 and then what is plus. Similarly, the computer visualizes the data, whatever it may be, a table of data or a tree data or a chart data, graph data, whatever it may be. And then it analyzes, and I mean, this analysis is the capacity which we are giving to that software or this computer, whatever it may be. Then hyper exponential accumulation of data. Yes, as I said, the data count, the data quality, I mean, apart from quality, the quantity of data has improved a lot. This improvement is not in terms of linear way, this is in terms of exponential way. And this is the right time for acquisition of the ability of handling unlimited data. Earlier, the people were just handling some data, like some less quantity of data. Now people started handling large amount of data, and this is the right time. Like you can see lots of advertisement in computer, like these many data scientists and these many data analysts are required in the software industry. Obviously, that is true. If you come across some IT parks and those things, and all, obviously you can, if you have a chat with the people who are working into industry, you will get to know how blooming this IT industry in terms of this artificial intelligence, deep learning, data science, and those things and all. So as an analyst, from my perspective, I can classify the data analysis in terms of 4 types. One is dimensional analysis, then one contextual analysis, 3 is physical analysis, and 4th one is calculative analysis. One, the manager from, let's take an example, the manager from logistic division of a company who cross checks after the receipts payment during each and every quarter. Simply to say, the first 2 are non-technical and last 2 are technical. Let me explain how. Say, for example, a manager who is not a technical person, he just wants to cross check, like what is the data that is coming and going out. So, for example, list of, payment and receipts and those things and all. If he wants to know, he need not, go and calculate each and everything. Let him ask a CA person, chartered accountant person, or an auditor or a cashier, whoever it may be. They just need to enter the data, and this data will reach the manager in a processed way. And in between tasks is what that we'll be doing as a data analyst. We'll be getting data from each and every data source. Say for example, cashier is one data source. Data from chartered accountant is another data source. Data from whoever it may be, like whatever the role he's been assigned with that company, we'll be getting all those data. I mean, we'll be extracting those data and we'll be transforming in the computer readable format, I mean, so-called a table format. And then we'll be giving this data, I mean, we'll be giving this data to this computer. I mean, and then we'll be loading this to visualizing methodologies, like whatever the chart or whatever the graphs in which we want to explain the data to the manager. This is what dimensional analysis. Dimension is like really visualizing the data from one dimension, from the dimension of a manager. Like this dimension need not be the same for all the people in the company. Say for example, the top management, like the managing director, might be having different dimension. He need not look after alone this movement of this cash alone. Similarly, the supervisor need not look after the cash. He just need to look after like what is happening in the goods section, like how much is the amount of goods coming inside, how much is the amount of goods going outside. This is what he needs to look into. So dimension analysis is like how we are going to, I mean, in which dimension we are going to view the data. This is what is called dimension analysis. Then contextual analysis. This contextual analysis is like solving a problem. Say for example, if the company is having a problem, like, I mean, not a company, maybe like our client has come up with a problem, and if he or she had asked me to give a solution for their problem, like this is what their problem is. In that case, only it's not like only this people or that department people will be looking into that. Say for example, like each and every people from different domain. Say for example, if they are coming out with a new project, in that case they will be asking us like what is the, how much is the cost required, how much is the goods required, how many persons are required, I mean human resources are required, what is the time duration of this process. And for all those things, each and every people, I mean, department will be sending a representative, and those all representatives work together and they will be getting a report, and visualizing that report is called a contextual analysis. So I think you might have got understood about the difference between dimensional analysis and contextual analysis. Dimensional analysis is like viewing the data only from one perspective. Contextual analysis is viewing the data from a single point of view, from different representatives. Then comes physical analysis and calculative analysis. These two are totally technical perspective. Physical analysis, like the raw data, what we are getting from each and every people, like if the data which I'm getting from a cashier, the data which I'm getting from another person, like so-called, you know, those data are not expected to be how the data are expected to. Say for let me tell you in a clear way. We'll be theoretically we'll be telling like this is how the data will be, but practically the data are not going to be like that. It can have fluctuations, and how the real data are need to be processed in case, and what are the problems are expected to come while processing such real-time data. This is what is all about physical analysis. Then calculative analysis. Calculative analysis is a higher standard of analysis. Like this is where data analysts and data scientists will do. Like they will be getting the data, the raw data from the data source, and they'll be processing. Say for example, many statistical approaches are there, like median, standard deviation, mode, then sampling technique, all those things. The data analyst will be doing all these things. Say there are a set of algorithms for data science, and they'll be checking like which algorithm is suited here for this problem. Like that, they will be working out, and they'll be getting like this is how the product, the data should be handled. And if they handle in that way, like how they can view or they can visualize the data. This is what is all about calculative analysis. Like where I have worked this physical analysis, like we'll be getting the raw data and we'll be processing whatever the fluctuations that comes while processing the data, we'll be looking into it. Then 5W1H in analysis, I mean not 5W1H analysis on Tableau. This is just nothing but 5W, where, why, when, what, and HSW. This is on like normal question. Whenever we are asked to do some analysis and give some visualized report, we need to check like why this analysis should be done on Tableau, what analysis should be done on this or Tableau, like based on which data, like when to when, like from when to when this data we have got, how this analysis should be done. Like these are the questions which we need to do. A need for visualization. Like visualization, we can say like simple. Just with the numbers, we can get idea, but we can't come to a decision. Because if data is less, then we can understand, okay, fine. We can understand from the data if the data quantity is less. If the data quantity is enormous and huge, then how will you come to a conclusion? Say, for example, let us take a 12-month span. In the first month, this is an example. First month, the sales quantity is 8, then comes 6, then comes 5, then comes 9. And if it is like this thing, the changes are very neck to neck, then it will be difficult for entrepreneur to proceed in formulating the rules of the company, like how to increase the, I mean, based on which factors he need to increase the human count, based on which factor he need to input the more investment, based on which factor he need to give more incentives and salaries to employees in order to boost their moral support, to enhance the company's profit and those things and all. For all these things, we need a visualized report, and this visualization is being now thrown in all the places. Say, for example, even in research areas, obviously, like there are plenty of projects that is going across the world in visualization for traffic management, healthcare sector, and education sector, and obviously in mining sector. Yes, in mining, then comes the space science. Wherever possible, we are visualizing the data, because this visualization will give you like what need to do next. Then comes like how to handle visualization. Like we all can do this graph chart, because almost all of us are familiar with this Microsoft Excel and those things and all, because we'll be creating a lament way of graphs and chart in Excel for paper presentation, those things and all at academic level. And from industrial perspective, like those graphs are not being recognized properly, because our client are like tier 1, tier 2. We will be classifying them for this type of client. Like we need to produce, I mean, we need to give a better product. Obviously, we'll be providing a better product for each and every client, but like obviously the stardom client will be treated, should be treated. I mean, the stardom client must be treated in an extraordinary way. That then only we'll be getting a good fame in the industry. That is how the industry goes on. Not only for our company, for each and every company. So like if we are being asked to visualize the data, we'll be giving, I mean, we'll be collecting the following information. We'll be first step, we'll be identifying the target domain, people, and requirement. First, right now I'm into insurance domain, so we'll be looking into the data from insurance, how the insurance domain works. Like what are the stakeholders, who are the stakeholders of insurance domain, how much amount of data that inflows and outflows through this company, who are the clients, how critical the data is for this people. And this is what is domain details is all about. Then comes people. Who are all the people who will be looking our data, and how they will be looking our data, and how frequently they will be looking our data. Say, for example, there are few companies in which the data is very important. Like they will be viewing the example, the difference in the data flow. For example, at first 1 hour, the data will be like a 10 GB per second, something like that. Maybe in another 1 hour, you can see it to be like a 40 GB per second. That is how the data might flow. In such cases, obviously, insurance domain is one of such domain where you can see the good enough fluctuation in the data. You can see like this much amount of data right now. Maybe after half an hour, you can see a lot of data coming. Then who are the people? Like in our project, like viewers are end users, like whoever insured in that company. Then insurance people, like who agents and similarly, those kind of people, stakeholders are now nothing but like those people who are involved in that trade and involved in that business. Then requirement, like if say for example, if the manager wants to view the data, what are the things which he needs to view in that report? Similarly, if end user, I mean the insurer or insuring, whoever it may be, like the person who had insured in the company, if he wants data, like what are the data which he or she needs to view? Say for example, premium amount which he paid, the premium amount like which he needs to pay, what is the next payment day, due date, and all those things should be, all these things should be given in a report. That is how the report should looks like. And each and every report should be secured. Say for example, I have insured in a company, and I want to find how much I have insured, I mean how much I have paid as a premium in the last quarter, and how much I need to pay in the next quarter, and what is the interest rate, and is there any possibility for the taking loan from that insured amount, and if we need to analyze all those data, we need to give them in a report. And these data are obviously so secure for me, and this is critical data, like no other person, if I'm a person X, then obviously person Y should not look into my data because it is my own data. So these are the requirements. Then gather and analysis data source. Gathering the data is a difficult task actually. Like since we'll be getting data from a different source. For example, in Oracle, there's a concept called service-oriented architecture. Obviously, you people might be knowing the SOAP concept, simple-oriented architecture protocol. Similarly, we'll be getting data from a different format. Say, for example, few people might be sending us data in Excel sheet, few people might be having a proper database, few people might even having cloud data source, and few people might be having some XML, similar kind of data source. From all these data sources, we'll be collecting the data, and the biggest process is like converting the data in a common way. For this, we'll be using mostly XML data or database, proper data. If the database is very good enough, then we'll be converting the data into XML. XML is the proper way because it is easily understandable by almost all these kind of data visualization softwares and data analysis software like Tableau, RapidMiner, Informatica, Power BI, etc. These are the top runners in this in visualization market and data analysis market as well. And analysis of the data source. Analysis of the data source is nothing but we have got some data, and we need to first, I mean, as soon as we get the data, it's not like proceeding further with putting the column, I mean, uploading the data, putting the column, retrieving the data and visualizing the report. It's not like that. Analysis like we need to find like what is the tenure in which the data has come. If this is the tenure, like the data has, if this much amount of data has come in this tenure, like how much is the data expected in the future. Then further we'll be for analyzing like who are all the people who are involved into this data, and what are the data, metadata, like say for example, for a premium payment itself, you can see a large number of metadata. Say for example, premium amount, premium due date, and in case if the premium is not paid on time, then a fine amount, then loan possibilities, then comes date of payment if it is already paid. Similarly, there are plenty of metadata. In such cases, what are the fields which we required for this visualization report? We need to first check it. We need to pick them, and then we need to check, like we need to, there is a process of refurbishing. Initially, we'll be come up with a report version 1. Then we'll be coming, further we'll be improving the quality of the report. We'll be giving this to client like each and every week or each and every month. It depends upon the schedule. Like based on that, we'll be analyzing this data source. Then frame the timeline of data source which needs to be visualized. Here, as I said before, the tenure of this data analysis is very, very, very important. We have got some data, and this data is between this period to this period. Usually, each and every company, like they'll be analyzing their performance from this tenure to last tenure. Like they'll be calculating what is the reason behind the profit falls or improvement, and how it needs to be improved further. All these data should be visualized. I mean, all these data should be analyzed, and then it should be given as a report to the top management team, maybe because they are the person who are involved in decision taking. Then ensure flexibility in visualization. Visualization is a report which should not be static. Say for example, like and Tableau has got a good enough options to make it more flexible, like filters, creating sets, groups, those things and all. um, Earlier, like in other tools and all, if you want to visualize the data, you can do it, but not up to the level of Tableau, because here in Tableau, in the report itself, we can embed this filter sorry, this filter, creating sets, and those things and all, which in other visualization tools it's not possible, like in Tableau. Ensuring individuality of each and every data in visualized content. And this is the good point, like which each and every Tableau data scientist and data analyst should keep in their mind. We can create some graph, but it should not be like an overview graph. This graph should have whatever the points which the person who is reading your report expects. Say for example, if I'm the person who had insured some amount in a company, if I need to find like what is the premium amount which I need to repay or which I need to pay in this amount, then I need to find the graph should not have only the amount which I paid. The graph should have the amount which I paid for each and every premium, each and every quarter, and like what is the interest which I have got on those things, and how much it has summed up into the maturity amount. All those things, all this data should be very, very clear in that report. That is how the report should be. One minute. Now comes data connectivity process. There are different types of data. I mean, different in the sense like majorly two types of data connectivity. One is hello.
I think somebody's is unmute yourself. Please turn
Hello.
off your mics, participants. Okay, so you can go ahead.
Okay. Majorly, there are two types of data connectivity. One is live data, and another one is extract data. Let me tell you, live in data, extract data. Like if the data analyst gets the data only once, then he need to save that, and then he need to process the data. That is extract data type. I mean, extra data process. Then another one is live in data. Live in data is like for each and every time. I mean, for each and every second, the data will come. I mean, it's just nothing but a streaming data. If the person wants to analyze that streaming data, then they need to go towards this live in data. Let me show you an example. See, can you see here the difference between live and extract? This option is only available in Tableau Online and Tableau Server, and not in Tableau Public and those things and all. Because it is an enhanced form of product when compared to Tableau. In Tableau Online, you can connect with these many data sources. But only in Tableau Public, you will not be able to connect with these many data sources. And these are few enhancement. And if you want to publish, then you need to go here and then you have to publish. Sign in, publish data source, and these things and all. Let me show you an example of live data. Say, for example, Okay, fine. Let me run this. Actually, this is a sample Python program which I have run to populate the data. And how it is going to populate the data means, this is the traffic data in this sheet. Let me show you the actual data. Open. I think someone raised their hand now. Yes, Dijit, what is this binary addition? Hello. Hello.
That's it, sir. You have any doubt? Um,
Can I continue?
yes, sir. You continue, sir. He'll just come up, I think.
Okay, fine. So here there are 20,000 data. This is an extract form of data. And I'm going to import this in Tableau. Traffic data sheet. So now I have connected it as a live. Let me make a simple graph. City. And I'm going to create a calculated field. Vehicles count. Sorry. It is going to take a count of how many vehicles has traveled. It is very yes, now it is varied. So in Bangalore, that particular period of time, 400 four-wheelers has crossed, and 372 government vehicles has crossed, 389 private vehicles has crossed. Now here 370. And in live data, if I'm getting the data continuously, then let me run this. And if you want to see that Python code, see here. This is to write the Excel data, and here I'm going to get the data from this random list, and it will be generating the data. Now I have only got 20,000 rows. If I need another 10,000 rows, so now I have got 30,000 rows, and this is that new file. Let me put that in the folder from which the Tableau will get the data. I'll make it as a Tableau old 3. Let me close this. Now let us refresh the data. Can you see the changes now? Earlier it was some 400, I guess. Now it has come to 595. So this is how the live in data connection works. If in case of extract, we can't see this variation. I think you all have understood what I'm trying to say, isn't it?
Yes, sir, we got it.
Okay, fine. Thank you for the response. So this is not only possible in Excel sheet alone, even in database. In database, database also, whatever the data source it may be, we need to give a refresh. This is like a refreshing at a developer's rate. In case if the user wants to refresh, then they need to refresh at the published day or day before, so they came across this dashboard concepts and all. Like maybe in future, someone else will be explaining you. This is how the live in and extract works. Okay, fine. Then majorly, what are the data sources which we can use? Which not like we can use. This is what in this. These are the data which are being used in industry. Like one is file data, either an Excel file, JSON file, TXT, and Tableau has an extraordinary ability of analyzing the data from PDFs as well, which many other softwares does not do. And in terms of a database, like all the database, say for example, MongoDB. MongoDB is one of the best NoSQL database which has come at a greater heights right now. Apart from the structural database, non-structural database or NoSQL, MongoDB is the best database right now, followed by this Cassandra, Hadoop, and those things. Hadoop is a good database, but it is like yet to develop a lot. It is in a primitive or a premature state. That is why, though there are many open source database in NoSQL, Enina, but still they are yet to reach its full height. Then cloud data. In cloud, we can see many data sources that can be connected. Say, for example, AWS, Google Sheet. Then similarly, other cloud data sources can be Azure, Microsoft Azure. All this data can be connected in Tableau. I'll give you a sample of how to connect with Google data sheet. Maybe in the next session. Then what are the drivers that are being used in data connectivity, and how the data accessibility varies with respect to role. All the Tableau developers, all the Tableau users will not be having the same role. The roles will be based on how they are using Tableau. Maybe one person might just want to read the data, one person might want to work on the data, and one person might want to include the data sources. Just for data source inclusion alone, we'll be having a separate role. There are 5 roles in that, and I'll be explaining all those 5 roles in detail. Maybe next in the coming session. And with respect to drivers, as I told before, like a Oracle driver, then suppose for each and every database, for Oracle we need a driver, for MongoDB we need a driver, for PostgreSQL we need a driver, for SQL Server we need, for Microsoft SQL Server we need a driver. Similarly, for each and every database, we need a separate driver in order to coordinate them. And there are many private source or third-party drivers that are existing in the market, which we can also use. But instead of going through those things, we can get all these things from Tableau website itself. For each and every database, they have only created a separate driver which we can use without any difficulties. So far, is there any doubt? Hello. Hello.
Yes, sir, we can hear you, sir.
So, like I asked, is there any doubt for anyone?
Femina, ma'am? Do you
Yes,
have any
yes.
doubt, ma'am?
Yeah.
Yes, ma'am. Go ahead, ma'am.
How we can access the online data? Open source data is extracted data, but if
Okay.
we go online only, we can use real time data. Is there
Yes.
any protocols to be followed to get the online data?
Not protocol, ma'am. Like you need to give the server details, username, password, schema, all those things and all.
So there must be subscription. Likewise, we should go and subscribe over there to get the data.
Subscribe in the sense like from Tableau perspective or from database perspective?
No, I
or
just
from
want to
cloud
know
perspective?
how to get a real-time data. That's the thing.
In order to get the real-time data, there are a few ways. I have worked in a scenario like the data will be pushed to XML file. That XML file will continuously get updated from the database or from the server, and this Tableau will pick data from this XML. This is one scenario, and another scenario is directly we will be configuring with the database using its database server, those things and all. I mean server IP address, username, password, those things and all. That is how also we can get the data. In case if you want to get the data from the cloud itself, then you need to enter the cloud details and the cloud. Have you come across this Dropbox?
Okay, okay, thank you.
So Ganesh sir is having it out like what is the difference between Rapid Miner and Tableau? Can you please elaborate him?
Actually, haven't worked in Rapid Miner, but Rapid Miner is a similar kind of software, nothing big difference in this, but visualization quality efficient like in Tableau, in Rapid Miner. That is a big difference actually.
Okay, sir. Thank you, sir. Participants, do you have any more doubts? Ganesh sir, yes. I think we are you're trying to speak something.
Yeah, I got it. I got it. Yeah.
Okay, sir. Thank you. Sir, and Debjit sir has it out like can forecasting of stock prices can be done in Tableau?
Yes, that can be done, but for this, like it depends on the other factors as well, like the company's growth, the company's financial policies, and those things. Yes, we do have a trend line concept in Tableau. Let me show you the trend line concept. Okay, let me show you a trend line concept. This trend line concept is like how the stocks price or whatever it may be is going to be in future. It is some kind of assumption, but not exactly. If it wants to be like, if you want to be more accurate, then you need to give more factors. For this, the Tableau needs a lots and lots of data. Say for example, just with the 3 months data, we can't predict the future, how it will be. We need at least some 3 years data so that we can predict next quarter, maybe another 3 months. Based on this, maybe for example, every year the company might have a good profit in first quarter, not like in second quarter. In that case, the Tableau will understand, okay, in the first quarter, the profit will be high. So accordingly, the trend should be good. That is what it understand and it depicts in the graph. Okay, the next question, can we directly feed the data which are collected from sensors without storing them? This is an intermediate file that you mentioned. That is XML. Yes, we can feed the data, but from sensor is in hardware and Tableau is software. Intermediate, we need something like maybe a file. We can use this thing, Raspberry. I think you might have heard about Raspberry. In Raspberry, you can get the data and you can store, and this stored data can be fed through Tableau. It is possible. That is how this traffic management projects and all being carried out through Tableau. For example, each and every sensor will be pushing the data to the cloud, and from this cloud source or from the database source, the Tableau picks out this data. Any other question? Would it be possible to create Tableau extension that integrates into a web application written in Django with Python? The web application would do read certain write operations to data source and send a response. Wait, let me make it simple. The web application will read and write operations to data source, sends back response to Tableau. Yes, it is possible. Like in Python also, like which database you're going to use, it depends on that. Maybe you'll be using Oracle, MongoDB, whichever the database you use. Accordingly, you need to install the driver and then you have to proceed. It is also doable. Have I answered your question, Anita ma'am? Is there any other question?
Participants, if you have any more question, please you can come online and mute yourself. You can ask him directly.
Sir, to work with the same, like just now the question is asked like web application and then in is integration with Tableau, right?
Okay.
So to work on that, which Tableau version or which Tableau desktop or Tableau public we can go for?
In case of database connectivity, obviously you should go to either Tableau Online or Tableau Server, because other Tableau products like Tableau Desktop or Tableau Public doesn't have that. I mean, Tableau Public don't have that capability.
Okay. So do we have access of that for a general user like us for
No,
Tableau?
you have only 14 days trial.
14 days.
Yes.
Okay. So to work with such application, then we need to buy that Tableau only.
In order to have hands-on, you can use the trial version because that is more than enough. In case if you want to do it in an external form of work, then you need to buy that.
Okay. Because to work with that kind of thing, we may need access of Tableau for like 2 months or more. Right.
In such case, I'll give you an example. I mean, it's not a proper way, but since you are doing it for a temporary purpose, I'll suggest you this option.
Okay.
Are you working alone in this project?
Yeah.
Okay, fine. In case you can get your friends' help or someone else, like you can use their own credentials to initially create, and you can first learn like how does it works. Then you
Okay.
can once you get a proper knowledge, then you can do a 14 days. I mean, trial. You can get a 14 days trial, and you can implement it very soon.
Yeah. Okay. 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 So, yeah, I got it. Yeah. That way it can be done. Yeah.
Yes.
Yeah. Thank you.
Okay, sure. I'll share the PPT.
Any more questions, participants? Anybody? So I think we can go ahead.
Okay, fine. Thank you. I have told like you need each and every. I mean, for each and every database, we need a separate driver, right? This is where we can get all those drivers. We can note down like when if you want, or else let me copy this in chat. Here is where you can get all the database relevant drivers. Say for example, if I need Oracle driver, I can get drivers for Oracle database, Oracle Electro, Oracle SBase, MySQL, MongoDB BI connector. And with respect to MongoDB, you all have you might be having a confusion like MongoDB is a NoSQL driver. It doesn't have a proper data structure. I mean, in a structure. In that case, how can Tableau get the data? Because all this we have seen in Tableau is like, say for example, view data. With respect to Tableau, we have got all these things in terms of a table. Then in MongoDB, it is like a JSON format. How for this we have a MongoDB BA. MongoDB itself has created a driver called BI, Business Intelligence Driver, using which we can get the data from MongoDB database, and we can make whatever the visualizations we need. Let me check whether I have for Teradata we have a database connector. For Spark SQL we have, yes, PostgreSQL also we have. For PDF we have, but PDF is not required. But they have given a adapter for Amazon. These are, I think even I don't have I don't have this much knowledge about. For Dropbox we have adapter. We'll not be using everything, but it will be as using whatever the database which we need. In case if you don't have a driver, then you need to go for third party. In my next session, I'll give you the list of database drivers. Third-party drivers alone, like which are being used popularly. My next session, I'll give you like how to connect with databases with the screenshots, and then I'll give you like what are the third-party drivers which we can use, followed by like what else I can do in my next session. Like I'll give you like what is the structure of the data workbook or data dashboard. What is happening. So I hope till here. Hello.
Yeah, sir. Yeah, it's
Okay. So we'll stop here and then we'll resume after a break. Is it okay? Okay, someone has asked a question. Drivers are needed only to integrate data from web. No, the drivers are also like if I have data in another machine, but I'm working in Tableau in another machine. If I want to get the data from that system, then obviously I need a driver because that is connected in a network. It is not only for cloud, but also for database that are connected across the network. Okay, I'll stop my sharing now.
Okay, sir. Thank you, sir. Thank you so much.
Welcome.